Okay, it's 7 o'clock and we're going to start right on time because we have a lot to get through before our guest speaker joins us, who tonight will be Dr. Samuel Ramsey. He goes by Dr. Sammy or by Dr. Bugs. If you've ever seen any of his videos, he's got a great YouTube channel. So welcome to the Portland Urban Beekeepers monthly August meeting. And I'm Cheryl Wright, the president. And just our little announcement about why should you join us formally. We have free library books, candles, molds, DVDs, and we have equipment rental, which includes manual, motorized extractors, a refractometer, the observation hive, a frame jig. And I've taken the bee vac out of service until someone wants to step up and try to make it not a bee murdering machine. The last time it was used, it sucked up a bunch of bees and just killed them. I think the vacuum motor is too strong for it. So, but we do have a swarm list and we have our Bee Buddy connections. We have PUB classifieds on our website, but more people now are just using our Facebook page, and you certainly don't have to be a member to be on our Facebook page. We also have free beekeeping opportunities at our club apiary, so you can support our mission for just $25 a year. Again, our motorized extractor is back, and we want to thank Micah Hamley, our engineer and our mechanic, who makes it work and makes the magic happen. And so it was a small part that was missing. There was a ball bearing at the bottom of the extractor that it sits and rotates on. So when you use this extractor, we're preferring that people who borrow it, it's $10 for about 5 days, but we do prefer that you have prior experience with it. There is some minor assembly and disassembly that has to happen to get it clean. It has to be balanced correctly, so it can be, I think you could hurt yourself with it. So if you want a brief tutorial, or if you feel really confident in your skills, just let me know. You can email me at president@portlandurbanbeekeepers.org and check it out, and it's available now. So just let me know. Our apiary work parties are at Green Acres. We restarted in July, so we're doing the first and third Sundays of the month, 10 a.m. to noon, and that's up on North Bradford Street, right next to the Cathedral Park, where the St. John's Bridge is. And our apiary manager said that we are going to have this first Sunday in August work party, and he's got a whole plan, which includes looking for mites, learning how to do mite inspections, do a mite count, and a general inspection. And then at some point, we're going to take honey off, and then we're going to have the motorized extractor available. We're going to have a honey extraction kind of party / lesson, so that if you're interested in using the motorized extractor and find it intimidating, please come to the work party and you'll get some hands-on experience with it. That's not going to be this Sunday's work party. It will be one of the future Sunday work parties. We'll keep you posted. So our Bee Buddy program has been doing really well. So it's for Portland Urban Beekeeper members who are newer beekeepers, or if you just want a friend to beekeep with, someone to help you lift your supers and help you organize your extraction and help you maybe just inspire you to count mites or do your treatments. Go to portlandurbanbeekeepers.org and you have to log in, click on the resource tab, click on the Bee Buddy map, click on the hot link, and that's to submit or change your information on the map. Use this form and fill out the form and choose if you want to be a mentor or a learner. And it'll take a couple of days for the information to be added to the map, but then you'll be on the map, and here is its current as of last month. I didn't update it for this month, but you can see we have lots of mentors and lots of learners, and you just click on wherever you're located or who you might want to be. I guess geographic is the whole idea with this. And so then you'll get the person's name and their email address, and you can contact them and get together. So our speaker lineup for 2021, again, we will be on Zoom until further notice. In September, Dr. Dewey Karen will be talking to us about Africanized honeybees in Oregon. Should we be concerned? In October, we're going to have Andoni Melathopoulos talk to us about pesticides. What are the real risks to our honeybees being urban beekeepers versus, agricultural beekeepers? It's a difference. And then in November, we're going to have Bill Hesbach, who's going to talk to us about thermal regulation, insulation, and ventilation in the beehive. Now, Last month, we announced that the honey tasting was going to be back in person, where we used to have our in-person meetings, which was the Multnomah Friends building, which is on Stark Street in Portland. And I just backed that up and made it tentatively. I'm not sure where the Delta virus is going to go. I would imagine that if everybody was comfortable and vaccinated, this would be a fairly low risk event. But again, I'm not really sure how this is going. So we're going to hold space for it up until the day. And then the plan is that we'll either have it or we won't have a meeting in December. So that's sort of how I'm going with that. If you have any suggestions, I'm open to them. Please email me. So our B School was extremely successful this year. We had more than 80 students enrolled, and we're still having people enrolling. The last date is August 19th, but the great thing is that we've recorded every meeting so that people who are joining in August can get access to all the other recordings, and then they will have access to them where they can look at them over and over and over again. So if you know anybody who wants to start preparing now for maybe next spring, they're welcome to join, or they can just wait until next spring, and we will be doing B School 2022 next year. And I imagine the Zoom worked really well for the B School. And then we do have the apiary experience, which is hands-on. So the plan is to still do it virtually. Okay, do you need a queen? Do you want to learn to raise your own? One of our beekeeping friends, Steve Gomez, he's a local beekeeper and he's in his final stages of qualifying for his master beekeeping title through the Oregon Master Beekeeper Program. He has locally raised survivor stock queens for sale at a good price. And he's also interested in hosting queen rearing workshops. And he's also wants to start a local queen rearing club. They have one of these up in Vancouver. But if you want one a little bit closer, maybe in Southeast Portland or a little bit further south, you can contact him. His email is there and his phone number. The Oregon State Beekeepers Association had a call out for the 2021 State Fair volunteers. So this is a lot of fun. It's August 27th through September 6th. They're going to have the setup on Tuesday, the 24th, and tear down on September 7th, which is also a Tuesday. They need 3 shifts per day covered, minimum two people per shift. But ideally 3 to 4, but there are no maximums. The shifts are there 10 to 2, 2 to 6, 6 to 10, and then on Friday and Saturday to 11 p.m. If you volunteer, you get a free day pass to the fair and parking right next to the booth. The theme this year is the Great Pollinator, and this is OSBA's centennial. They've been in existence for 100 years, and so they're really excited about that. And also don't forget that if you have hive products, that this is a great time to compete if you're into that with honey and wax and other products. So if you're interested in volunteering, you can contact Bonnie King. Her contact information is on this slide. And then there's there's a Google Docs spreadsheet that you can go and sign up. So you can access this when you watch the recording. So specifically, the OSBA has called for people who are willing to carry an observation hive with a nucleus hive in it. They want each nuke to be there for two to 3 days. And we have this observation hive. It's all cleaned up and it's ready to go. So if you really want to do something like that, just let me know. You can come by and pick up the observation hive. They also want an observation hive coordinator, but they prefer someone who lives a little closer to the fairgrounds, and that would be in Salem. They need people to help set it up and tear it down, especially if you have construction expertise. The booth will be indoors, and so due to this ongoing pandemic, they're asking you to please be prepared to wear a mask. And I would just add, being vaccinated would be a big plus. All right, I'm going to hand it over to Dr. Dewey Caron, and he's going to discuss his slides, his Pacific Northwest Honeybee Survey, which is an annual assessment of overwinter losses. And that's the URL where you can find this information and more. So Dewey, I'll scroll down and let you talk about your slides.
Okay, thank you, Cheryl. Good evening, all. As Cheryl's indicated, in April, I'm asking you for some information And this year, a little bit late, but I'm getting your information back that you gave me on the Pacific Northwest Honeybee Survey. I ask a couple of different types of things. The first part is the losses, and you can see for here the figure 1 of the report for the Pacific Pub Group by county, by state, and by county. So this is Washington State and Oregon State backyarders. The Washington State are the numbers above, and then the state of all of those for Washington State is the first orange line. The second group are the Oregon State by associations. The number next to the name of the county group indicates the number of returns. So if you'll see about halfway down in the Oregon, you'll see our group, the Portland Urban Beekeepers, 52 individuals, where the pointer is, 52 individuals filled out a survey, and annual losses for that group, average annual losses were 40%. So I present losses by the type of hive, by type of origination, a number of questions related to losses. You'll see that it's just a little bit higher than the state level losses. That's everyone, the 328 individuals in Oregon that filled out a survey, including the 52 from Portland Urban. Next, if you would, Cheryl. So in the report, you'll find information that is related to past histories as well. So the graph at the top looks at the average for this year, that 40%. And then I have charted the average losses for the members of Pub Group going back now 8 years. So our losses of 40% this year, you see, were just 2% higher than last year, but are a little bit higher than the average. The state average is 40%, and that's right where pub losses were last year. Now, for then the second part, I've asked about information about some of the managements that you do. So, for example, feeding, winterizing, sanitation, monitoring, screen bottom board use, et cetera, and chemical, non-chemical issues. So the bottom graph there shows the individuals that different methods that they use to monitor mites in this group this past year. So you can see that 63% of the individuals said they monitored with sticky board, 50% with alcohol wash, and you can then see the numbers across. These numbers add up to more than 50% because many of you do use more than one monitoring method. The monitoring methods are then keyed also to 2 months. So these are then keyed to levels of losses. So for the individuals that have, for example, been feeding dry sugar, I break out that number. The number of individuals that use dry sugar are indicated on the response, dry sugar, and then the level of losses. So all of this is posted. Cheryl has the URL that was listed, or if you just simply use your search engine, PNW Honeybee Survey, and then click on individual losses. The state report will be up. Now it'll be up. I haven't got an assurance it is yet posted, but should be within later this evening or hopefully within a day or two. Thank you all. Thank you to all the pub members that responded with survey information. And even if you did not participate, I hope you'll look at it and equate to the types of things that you do and see how your neighbors did, those members of pub, how they did with their beehives using the same methods. Thank you.
Okay, Dewey, thanks a lot. That's great information. So, this is some data that we have. Now, this does come out of California, but it gives us an idea about where we're at in the bee year. And so remember that in June, our adult population was peaking and our brood population was peaking. And now as we're going into August and September, we're starting to have lower levels of both brood and adults. And this is the time now when eggs are being laid, and probably a little bit later, maybe in early September, where your eggs for your overwintering bees are being laid. And this is why it's so critical to start carefully looking at your mite loads and keeping in mind that that's also a marker for your viral loads. And we don't want those overwintering bees to go into the winter sick with a bunch of viral infections. So our mites, they're starting to build up now, as you can see from this graph. Again, this is California data, but the mites are starting to go up, and they do go up in an exponential fashion. So we just have to keep an eye on them and treat if you're a person who believes in treating, which I do. So what should we be doing in our hives in August? So the nectar dearth is here. Do you have a feeding plan? Carbohydrates and protein is something, especially for the weaker hives, if you want them to get through the winter. If you have new colonies from this spring, continue to feed and monitor. Varroa mite management's number one. Robbing screens, and if your colony is successfully overwintered last year, your honey harvest is something we all look forward to. So I just put this little graphic up. I'm not going to go over it. This is not we're not doing a discussion today on Varroa mite management, but if you do still have the Zoom link to Ramesh's talk in June, he talks a lot about the Varroa mites and some of the newer thoughts on management. But here's our standbys: Apivar, Apiguard, Apilife, and Formit Pro. And so this will be up on the recording. You can go back and look at it afterwards and read it carefully. And then you can also go to the Varroa mite management decision tool, which the URL is here, and it gives you all different ways to think about managing mites. Robbing screens is a very easy thing to do. You can get a fancy one like Linda's Bees over here, where she has it's a nice rigid structure, or you can do like your president does, who's cheap, and she goes to a hardware store and gets Velcro and slaps it on. And this I think it does a great job. What it does is it allows the bees to continue to get ventilation during the hot days of summer and early fall, and it leaves a smaller area on the sides where the bees only have to guard these smaller areas. It just makes it a little harder for the yellow jackets and other bees to come in unnoticed. And if things get really intense, I just kind of leaf over these ears and pin it and just give the bees just about a thumb's width to come out. But anyway, it's something that we do need to pay attention to. You can use the cleats, just reducing the entrances. You just give the bees a chance to guard their entrances. So I'd just like to review what a good brood pattern looks like versus a not good. So over on the right-hand side of your screen is a spotty brood pattern. If this is in your hive, then you might want to think about requeening. But ideally, you have a nice solid brood pattern, but it will be, as I said, contracting as we get going into the fall months. Your healthy larva, you have an egg in the very center of each cell, and each of your C-shaped larvae are sitting in a nice pool of kind of a whitish liquid. So that's what you're looking for. Remember, if you see multiple eggs in a cell, that you probably have a laying worker, and that's not really great. Or if you don't see eggs at all, you may have had a queen event. American foul brood, this is the season for that. And this is something that's not really super common, but if you have it, you need to be aware. It's have very characteristic greasy-like pattern. It has a very characteristic foul odor. If you hold the frames at a certain angle, you can see the scale on the cells. You can't see it looking straight down into the cell. You do have to hold it at an angle. And if you see this, PUB still has our EFB, AFB task force. So if you think you've got something like this going on, there's a form you can fill out on our website, and we will come out and we'll help you look. And we have an AFB, EFB rapid test kit. It looks like a rapid strep or a pregnancy test, and we can see if that's what's going on. The small hive beetle, we talked about that a little bit last month. It's still here, so do keep your eye out for it. It looks like this, like this. It's not terribly small. It's not small like the varroa mite. It's fairly easy to look at. It's fairly easy to see, but you have to look for it, and I think that's the key. We have this is an extension identification card that if you have any questions, you can get one of these from the Oregon State University, probably from the Ag Extension agent too. But our season right now is yellow jacket and other hornet season. And I want to really impress upon people that this is the time when PUB gets a lot of swarm calls. And it's key that if you collect a swarm or if you're interested in a swarm, you have got to ask the person who's reporting what they look like, where they're coming from, and what color they are, and ideally get a photograph, because this is the time we get all kinds of calls for yellow jackets. And I know that you don't want to suit up and go out and find a big bunch of yellow jackets. So be very suspect when people start calling you about bee swarms. So this is what the yellow jacket looks like. And I also want people to remember that yellow jackets are an important part of the environment. They are carnivorous. They do take out our drones. And that's there's nothing better than recycling a drone into a yellow jacket nest. I mean, otherwise they're just going to go to waste. And if your colony is strong, it can hold these yellow jackets off, especially if you have a robbing screen. So this idea of standing out there and trapping yellow jackets and poisoning them with fipronil and cat food and all of these other things that people do, the bottom line is if your colony is a weak colony, it's not going to make it through the winter. And if you've got 50,000 yellow jackets swarming your beehive, it's a weak colony. I've been there. I can vouch for it. It's every time that's what's been going on. So the yellow jackets are just sensing pheromones that the bees also can sense. So they may sense a weak or a queenless colony or just a very weak colony, a varroa infested colony. So again, it's worth a good inspection if you're having a real yellow jacket problem. The other calls that we get a lot this time of year are for bald-faced hornets and nests. So people see this and this nest up here on the right side of your screen, and because there is popular literature out there with this picture, this graphic being shown as a beehive, then people see it in their trees and they call you and they want you to come and save the bees, right? So get a photograph. Don't go out there and mess with a bald-faced hornet hive. It's like, the girl who kicked the hornet's nest, it's a problem. Don't do it. So if you get a swarm call and you answer it, call, query, ask for photographs, and that will cue you in as to what you're really going out and facing. Now, there are a lot of beneficial wasps, mud daubers, these little paper wasps. This thing, which looks like it would kill you, I saw it on my deck. I just completely freaked out. But this big thing on its back end, that's an ovipositor. It's not a stinger. I mean, we know that stingers are modified ovipositors. That's, something different. But this insect does not sting you. Yes, it looks big, but it's very harmless. So please don't be spraying Raid or any other type of insecticide on these little guys. They're great pollinators, they're beneficial, and they're not going to harm you or your bees. Does anybody have any questions? Okay. So our guest tonight is Dr. Sammy, also known as Dr. Boggs. Dr. Sam Ramsey, he's a USDA researcher. He is the entomologist who, as a student, made the breakthrough discovery that the Varroa destructor mites are not relying on hemolymph or bee blood for sustenance, but instead they're actually eating the bee's fat bodies, which is an important organ for storing nutrients, regulating immunity and hormones, as well as pesticide detoxification and other critical functions. So tonight he's going to talk to us about the Tropolaelaps mite, which is an emerging global threat to honeybees. It's not here in the United States or North America yet, but it's something that needs to be on our radar so that if we're doing an inspection and we see something that looks a little funny, that we start letting people know so that we can continue to monitor and intervene as needed. So let's see if Dr. Sammy is on the call.
Hey there, Cheryl. How are you?
I'm good. How are you?
I'm doing pretty well, and
There
thank you
you
for that
are.
wonderful introduction.
All right, let me make you co-host.
All right.
And thank you for taking the time to come and join our bee club.
Of course, I'm really glad to be here. Let's see. Move my chair a little closer. All right. Everyone can hear me well, right?
I hear you great.
Great. I see Dewey shaking his head, so I know I'm doing right. All right.
Okay.
It's good to see you again, Dewey. It's been a long time. Let's see. I'm going to share my screen and hopefully not give most of you nightmares, but we'll see. Now, as you've already heard, today we'll be talking about the parasitic mite Tropolaelaps mercedes. Now, this work is kind of going to leave you in a little bit of a lurch because I wish that I could talk to you about this project as if the entirety of it is already finished. But this project was being conducted during the pandemic, and as a result of COVID restrictions, the project had to be shut down. I had to come back to the US. And so there's a whole segment of this project that has yet to be completed, but there's still a lot to tell you, and I'm looking forward to doing so. So first of all, thank you for that wonderful introduction, Cheryl, and also for all of the advice that you've provided to people about their bees. The segment where you talked about Varroa and then small hive beetle and other creatures that get into colonies, we're hoping that we never have to add any more creatures to that list, but it's always possible that we could. There are parasites and predators of honeybees that exist in other parts of the world. And as we continue to globalize as a global community, as things continue to be more and more connected and tight-knit, creatures move around. And so we've got to be prepared for that and ready for what they may entail for our bees. This mysterious mite that you're watching on your screen right now, those little dots that you see darting about on the comb, those are Tropolaelaps mites. And this video is not sped up. It was taken by Dr. Lilia de Guzman in Chiang Mai, Thailand. And I'm glad that she took this video because it helps to represent to people that the issue that they're seeing here is different from the ones that we're used to. People are used to seeing the slow, bumbling Varroa mites, but this is a different beast. This is Tropolaelaps mercedes. And I wrote a paper 2 years ago now about how they're an emerging threat to Western apiculture. And the goal is to get people to become more aware of what this organism would mean were it to ever get into our country. Now, the geographic range of Tropolaelaps mercedes has been shifting. It's been shifting quite dramatically because this organism is really good at moving from colony to colony. And as a result of that, it's also pretty good at moving from country to country. Originally, Tropolaelaps mercedes was present in just this region of the world, so Southeast Asia, not the entire region shaded in red, just a subset of it. So in Burma, Thailand, Laos, Cambodia, Vietnam, Philippines, Malaysia, and Indonesia. And then it began expanding its geographic range in a way that should look familiar. It moved into China and India, started spreading into the Middle East, and hopefully you already know this story a little bit. And if you do, you've probably been paying attention to the spread of the Varroa mite, which also moved around the world in a similar manner. But it's also important to track how much more quickly this is happening than with Varroa. Varroa moved more slowly. Tropolaelaps seems to be moving more quickly. And I want you to look at the two geographic range maps that you're seeing here. The one on the top, at the top of your screen, is the distribution of Tropolaelaps mercedes in the year 2002. Yes. So when this geographic range map was first established, it was a bit of a concern that these organisms had moved into China. And China was a big deal because we were under the impression that because it's very cold in a lot of areas of China, that these organisms would not be able to establish consistently reproducing populations. They need brood in order to survive the entire year. And so we were kind of happy with this idea that they would never make it into temperate regions of the world, any area that has a winter or an extended period of time in which the bees are not producing brood. And then, well, these mites changed our entire perspective of how this works. They moved into China and have been consistently expanding their range more and more northward into regions of the world where we did not think they could actually dwell and be successful. They've also moved into Korea, but something that you may find a bit concerning here is that Kenya and Tasmania are shaded on this map. And I was really shocked when I first saw this too. But I haven't seen any papers indicating that they're actually in these areas. And so I did some calling around, actually contacted the bee inspector for Kenya. I had to make some contacts in Tasmania, but found that this is actually from an errant identification of a type of mite called a pollen mite. So there are some Neocephalalaps mites in these areas that can, it's a very strange genus to say, but that's the genus for a group of pollen mites. These mites look fairly similar to the tropy mite and confused people a bit. And so that's the reason why that earlier geographic range map has that incorrect shading. This particular geographic range map was originally the only one that was present for Tropulalaps. And so I have created an updated map with new data and information that I've collected in my time in Thailand. What should be really concerning is to see now that this parasite has moved into Oceania and into the Middle East. So it's officially out of Asia. When this map was first created, this organism was being discussed as an Asian parasite, but that is no longer the case now that it is in the Middle East. And with its movement into the Middle East, we can see exactly what happened with Varroa potentially happening here. As Varroa got into the Middle East, it was able to easily move into Europe. And from Europe, well, the world is your oyster from there. There are a lot of trade routes that run through this region of the world and can easily move the tropy mites to South America, North America, and well, there you go. Now, Varroa's geographic range map expansion was pretty similar. When they were originally found only in Southeast Asia, and then things began to change. And when they began to change quite rapidly. As these parasites moved out of Southeast Asia, they moved into China, into India, same spread pattern as the tropy mites, and then into the Middle East, and from the Middle East into Europe in the 1970s. And after that, it was only 10 years before they ended up in the United States. So, how much of a problem would that be? Well, the tropy mites have a similar life cycle to Varroa. So if they ended up in the United States, we could expect that we would have another parasite to deal with that is a brood parasite of our bees. That means that these parasites will enter open brood, and that is the only place where they're capable of reproducing. When that brood is sealed by the adult bees, they are able to start their reproductive processes. And unfortunately, things get quite dodgy from there. So it's the process of cell invasion and the reproductive processes that can really leave you with the impression, okay, it's just another Varroa mite. Not quite. There are a few key differences. Now, Varroa does develop things like pesticide resistance, but it actually develops it fairly slowly in the grand scheme of evolutionary change. And one reason that we've posited for this is the fact that Varroa destructor happens to be an organism that typically only gets the opportunity to mate with its siblings. Under most circumstances, at least if they're going into worker brood, in circumstances of drone brood that can support a lot more mites and oftentimes does. But usually a single female will enter a worker brood cell. And when she enters that cell, she'll begin to reproduce. The very first egg that she lays will be a male, and that male will have to mate with his sisters, creating some level of inbreeding and ensuring that there won't be a huge amount of diversity spread about in that population. But the tropy mites are interesting in that they have more options there. The female lays oftentimes an equal number of male and female eggs. So the first egg that she lays can be a male or a female, as can the last egg that she lays. But when that cell is uncapped by the newly eclosed adult bee, the mites all leave, both males and females. In Varroa, the male mites die. They are not capable of surviving outside of the cell. After they mated with their sisters, they've done their job. There's nothing more for them in that world. But the tropy mites have the males able to leave these cells as well. As the males leave, their ability to move about along the comb allows them to meet up with females that they are not related to and creates a population of mites with a much more robust genetic code. This may be the reason why we're already seeing that Tropulalaps has a much more diverse genetic code than what we've seen with Varroa. And then in addition to this, these mites are less vulnerable than Varroa. This period of time where they're on the adult bees, in a lot of different groups of mites, it can be referred to as a phoretic phase. A phoretic phase is a period of time where a smaller creature will use a larger creature as a mode of transit and only transit. It will not feed on that creature. Were it to feed on that creature would just be any other parasite. But the phoretic mode is one that lets you know that this organism needs that creature to move it from one location to the next. We don't see that with Varroa. Varroa will actually feed on their host. So we've been using the term phoretic inaccurately toward Varroa. But the tropy mites do feed, or do not seem to be feeding on those adult bees as best we can tell at this time. And so when they attach themselves to adult bees, they don't actually remain on them for very long. If they're using them as a mode of transit, they don't need to go very far. They're moved from one location in the colony to the next. And in a matter of hours, they leave the body of that adult bee, go right back into the cells, and continue the reproductive processes. So there are some differences that are really important. That particular difference is extremely important to the process of treating, because the period of time where these mites are on adult bees is the most vulnerable period in their life cycle. The vast majority of treatment options that we have available to us for treatment of Varroa target the period of time that Varroa is on the adult bees. There are very, very, very few options that actually target the period below the cell capping, because that wax cell capping is really good at repelling chemicals. It makes it very hard to treat that population of reproducing mites. We also know that the tropy mites are about a third as wide as Varroa. And also, I should say, Tropulelaps mercedes is very difficult to pronounce. It's actually impossible to pronounce for many of the Thai people that I worked with. Some of the sounds just don't exist in that way in their language. And so I've taken to calling them tropy mites because I knew that the individuals that I was working with would be better able to pronounce that. And I've found that native English speakers are also better able to pronounce tropy mite rather than Tropulelaps mercedes. So you've got your Varroa mites and your tropy mites. Now, Varroa destructor is this oblong, wide parasite that bumbles around in the colony. But the Tropulelaps mite, the tropy mite, is actually different in its shape. It's compressed in that way such that it is about a third the width of Varroa, and its ability to move rapidly along the comb as a result of this change in its body plan. Its legs are positioned around its body in a way that allows for maximum mobility and really rapid locomotion. So that makes them a lot more difficult to catch than Varroa. Oftentimes you will see honeybees going around uncapping cells inside of the colony. Where there are Varroa mite inside of the cell, oftentimes they can grab that mite and remove it from the gene pool. But for tropy mites, they have a much more difficult time grabbing these mites. I've seen no success in them actually grabbing and killing a tropy mite, both because of its small size and its remarkable speed. And in addition to this, we know that the tropy mites are very, very, very destructive in the way that they feed. As damaging as Varroa is, and the fact that it causes a lot of internal damage by feeding on these bees, it tries to limit the amount of damage it causes by only feeding on one area of the bee's body. And so it will pierce the exoskeleton, the soft, squishy, membranous mass that makes up your larvae. It'll pierce through them and it will feed through that same hole consistently as it's developing. The tropy mites do not care. They will feed all over the bee's body. Whoops, bumped my mic. They will feed all over the bee's body. And so you can see all of these blue marks. We used a vital stain. It interacts with damaged cells on the surface of the bee and stains them a particular color, in this case, a dark blue, that allows us to see all of the places where the mite wounded the bee. Now, you might be thinking, wow, well, that's a substantial amount of wounds that it's inflicted, but that's probably over the course of many, many days, right? No, that's over the course of several hours. These mites feed repeatedly over the course of a day, and each time that they feed, it doesn't seem like they have any intention to localize their feeding to just one spot. They keep moving all around the body of the organism, biting new holes each time they feed and causing quite a bit of damage. Why is that concerning? Well, faithful are the wounds of a mite, and they cause some serious problems. When they feed, there is something analogous to scar tissue that forms just below the surface of the exoskeleton of the bee. And as it forms in that wounded area, that region of the bee's body becomes inflexible. So if that region is destined to become the antenna of the bee, that section where they were fed upon is immobile from that point forward. Now imagine if instead of the antenna, that was the bee's leg. That region of the leg would no longer be able to articulate up and down such that the bee can place its flat tarsus on the ground and walk normally. If they're feeding in regions of the body that are destined to be the mandibles, they can create obstructions in the mandibles where you can't get the full articulation of them. And in that way, you can see how these organisms, even without viruses, can disrupt the progression of the colony. But that doesn't mean that viruses are not a part of this process. Varroa destructor can transmit a number of viruses to bees. Direct vectoring, we know for 5 different viruses for sure. There are 8 others that we suspect that these mites are capable of directly vectoring, or that they are just generally associated with the virus itself. For the tropy mites, we only know of 2. But we only know of 2 because only 2 have been tested so far. So it is very possible that, similar to Varroa, there are many, many other viruses that these parasites are capable of transmitting to the bees. Now, you may be noticing a theme here. There are some basic things that we know about this organism, but there's still a lot up in the air as to what it's doing. We know that the populations for these parasites grow very rapidly. And it's, at first, individuals thought that it was because their eggs hatch more quickly, but their eggs only hatch a few hours sooner than Varroa's. What seems to be the case is that because they so quickly re-enter cells to continue their reproductive processes, they seem to be very, very, very capable of starting new populations very, very rapidly. So think about it. Varroa destructor spends between 3 and 13 days on adult bees every time it goes through its reproductive processes, with the average being about 1 week, about 7 days. So every time it goes through its reproductive process and it has maybe 1 or 2 viable offspring, then it suspends any reproduction for a week, sometimes 2 weeks. For the tropy mites, they will only suspend reproduction for a few hours. This allows them to reproduce so much more quickly than Varroa. Earlier, both Dewey and Cheryl were reminding people that populations of these mites can grow quickly and need to be monitored. And someone was saying that they are looking forward to taking another look at the mite levels in their colony. They've already checked this month. They're going to look again in September. It's well worth considering that a population of Varroa mites can double every 30 days. A population of tropy mites seems to be able to double every week. That is concerning. Listen to me. These are not good things. So, what do we know about this parasite? We know enough to know we don't know enough. What I can tell you for sure is that if these parasites arrive in the United States, they are going to shut a lot of things down very rapidly. And here's the major concern. The ports where, based on my own research of these organisms and what we see going out and coming into the United States, the ports where it's most likely that these parasites would be found, areas like Florida, California, are really, really, really concerning places. In Texas, because people oftentimes put their colonies there for overwintering, or there are regions of the country where there's a lot of migratory beekeeping. And so it would be very difficult to contain these creatures if it were the case that we found out that they were in the country after people had already started moving their colonies for migratory beekeeping. They could easily spread to a lot of regions of the country before we even have the opportunity to start quarantine, control measures, or eradication. So we don't want this to happen. But it is possible that these organisms will arrive, and it would be foolish for us to decide not to take any action simply because it is our desire, our firm desire, that they never arrive. So then there are questions that we absolutely need to answer about these creatures. And here are some of the things that we don't know yet, and it may surprise you, some of the fundamentals that simply are not clear to us as of this point. Similar to Varroa, just what, 5 years ago, we don't know what these parasites eat. We're just finding out that Varroa destructor feeds on the fat body of honeybees, both the adult and juvenile bees. But what do the tropy mites consume? Well, if you were to look at the literature, you would say, this paper says that they feed on the bee's blood. But I've spoken to the researchers who were the first to write that in their papers, their dissertations, their theses, their work about this. And what they've told me is that, we believe that the tropy mites feed on the blood of the bees because the Varroa mites feed on the blood of the bees, and they're very similar parasites. Now, you guys might have an idea as to why I, in particular, would find that to be just a wee bit funny. Because they were saying this to the guy whose thesis research was about to be published, and explained that that was not the case. And it's through this system of consistent assumption that we've ended up in these problematic settings to begin with. And so we need to actually conduct experiments to determine what these organisms are feeding on, because this guessing game is not the way to go. So what do the tropy mites eat? We don't know if they're feeding on the fat body of the bees. We don't know if they're feeding on the bee's blood, the hemolymph. We don't know if they're feeding on a different tissue entirely, but we really need to know the answer to that question, because what an organism is feeding on, what a parasite is feeding on in a creature, determines the level of impact that it has on that creature. It determines its virulence and its pathogenicity, and we have to be able to understand that, to be able to mitigate its damage, and really to be able to effectively develop control measures. Do they feed on the adult bees? Currently, it is my hypothesis that they are not feeding on the adult bees, at least not in any way that is substantial. If you confine them to simply a cage with adult bees, they do not survive for longer than about 48, between 2 and 3 days, between 48 and 72 hours. The vast majority of them are dead within 48 hours. There are a couple of outliers that I've seen survive a bit longer. Within the colony, they don't try to feed on adult bees, it seems, when they start going into a period of starvation. They'll actually go into brood cells of brood with very young larvae. So not simply the L5 larvae, not simply larvae that are about to be capped. They'll go into brood cells with larvae at only their third instar, your L3 larvae or L2 larvae, and start feeding on those. And the problem is that they frequently kill those larvae in the process of feeding, because a larva that's not mature simply doesn't have the tissue to spare to be fed on by a parasite of that size. So there's still some things that we don't seem to know, and one of them is a fundamental question here. I'm going to attempt to prove this utilizing a system of fluorescent biostains to see if we feed these fluorescent biostains to the adult bees and then expose them to tropy mites, what happens? What does it take to rear these organisms off host? If we want to be able to test things like pesticides that we can use against the tropy mites, we need to be able to keep colonies of them in the lab in regions where these organisms already exist to attempt to test these pesticides. How do they spread? We actually don't know the answer to that question, and that's a big question. When you're dealing with, think about when COVID first started showing up in the world. A big question for us was, what is the mechanism of spread for this infectious disease? It's the same when there's an infectious disease spreading amongst bees. There was a time where you could not find hand sanitizer anywhere because everyone was worried that you needed to wipe down every surface, you needed to slather your hands in hand sanitizer, because we weren't sure if COVID was spread through something called fomites, through residues and things on surfaces. And then later we found that it's a respiratory virus. It's airborne. It's able to move on air currents, especially in droplets of saliva and sputum that are light enough to be carried, which is why things like vaccines are a really good idea. So these concerns, just a little public service announcement there. So these concerns that we're having about the trophy mites, or I should say a concern that I've been taking to a lot of people within the government now, and I'm really, really, really glad to say that different agencies are taking notice of this. We've now gotten the EPA involved, and there's a lot going on now, but the fact that we don't know how these organisms spread yet is really concerning. Varroa has the ability to actually slip its body between the plates that make up the bee's body, and that allows it to be kind of locked in place when the bees are flying around to different locations, and it allows for honeybees to be the primary means of moving Varroa from colony to colony. Varroa aren't going to walk out of a colony and walk into a new one. That's not their mode of transit, and they certainly cannot fly. So without the bees as a mechanism of getting them from one location to the next, they're not going to be great at that process. Well, the trophy mites don't actually have that ability. They don't wedge themselves between the plates of the bees. Their bodies are shaped entirely the wrong way for that. And we found that if they try to remain on adult bees for lengthy periods of flight, they're often blown off in the process. They are not aerodynamic and can't really reduce their center of gravity well enough to be able to stay on the adult bees for long periods of flight. It's one of the ways that we actually found this out from the bees that they attached to in the wild. So the giant honeybees, which are their original host, they use their migratory patterns as a way to reduce populations of trophy mites. If they find that they have very large populations of trophy, they will go on a very long migratory flight and get rid of them. They will leave everything behind in the comb, and they will start over and build new comb in an area farther away. What remediation methods are effective at controlling these organisms? We really need to learn the answer to this one quickly. This is one of the first questions that needs to be answered, because if this organism were to show up in our country, it'd be very important for us to know how best to remediate them. And we need to pay attention to the other countries in the world where this organism is already destroying economies. This organism collapsed the honey producing industry of Pakistan. In early stages of this parasite first emerging as a parasite and problem for Apis mellifera, the Pakistani beekeepers had recently decided, we want to get in on this whole honey production thing, but we need to switch bees. We've been using Apis cerana primarily as our means of producing honey, and they're just not very efficient at it. Apis mellifera can produce more than 10 times as much honey as Apis cerana can in the same period of time. And so they decided to import a bunch of bees from Australia, thousands and thousands and thousands of colonies to use as their means of establishing. And then the trophy mites moved in a few years later and destroyed the entire population of Apis mellifera. Every single colony. Pakistan lost all of its Apis mellifera to the point that they had to call up Australia again and get an entirely new shipment sent in. So it's actually very important for more than just the United States, but for other regions of the world. I'm really looking forward to publishing the data that I've been collecting about means of remediating trophy mites, not just for us in the future, but for these other countries that we consider to be developing economies. And so it is not until these parasites reach a developed nation where we typically start thinking, oh, we've got to figure out something to do about these because now they're messing with all the money. I think these other people's livelihoods are important too. So we need to think of remediation methods like potential use of things like formic acid. Is amitraz an option? What about heat? What about brood breaks? How are we going to control these parasites? We also need to know what's happening under the cell capping. The life cycle of this organism is very mysterious to us because there is an entire period, the vast majority of its life cycle occurs under an opaque cell capping where we cannot see anything. When those bees cap that cell, everything that happens under that cell capping is a bit of a mystery. We have learned that we can uncap the cell and that the bees will continue developing normally. You can't uncap the cell and have the parasites continue developing normally. That influx of air immediately triggers them to stop the behaviors that they were conducting before. And so it's very difficult for us to actually get a read on what these parasites are doing, aside from uncapping the cell and taking a picture of the exact thing that was going on the moment we uncapped it. And then that's it. You're done with that sample. We need to know more. What do the trophy mites do when they're interacting with varroa mites in the same cells? And are they competing? Are they cooperating? Are they synergizing into a worse parasite than the sum of their parts? What's happening? And can both parasites reproduce on the same host? There was data originally saying that varroa mites and tropy mites would not enter the same cell and could not reproduce on the same host. I don't think that that's accurate. And just a moment, a little thirsty. So, how is the host impacted by these parasites being in the cell with them, both varroa and tropy mites? It turns out that varroa and tropy can share the same hosts. They can share the same colony, and this happens substantially more frequently in areas that have a winter. Tropy mites seem to outcompete varroa within tropical circumstances. But in areas that have a winter, it seems to slow down the reproductive rate of the tropy mites, such that the tropy mites and the varroa mites are present inside the same cells and the same colonies. So then what happens? So here's something that I find really exciting. You are currently looking at the very first video ever captured of, actually, let me see if I can make that a little bit easier for you to see. You're looking at the very first video ever captured of the tropy mites inside of, are we good here? Oh no, did it freeze? All right. Of tropy mites inside of a brood cell, a sealed brood cell. This is something that is very, very, very difficult to actually do. I had to develop a system for figuring out how we could visualize these organisms, because obviously getting a camera small enough to fit it into a brood cell is nigh impossible, at least if you're going to get it in really good resolution like this. And so we actually developed a system called Mite Insight, where we can actually see what's happening to the mites in this process. Now, the Tropulate Labs project has been divided between these two goals. I want to visualize the mites, something that we've been calling the Cite the Mite initiative, and then we want to kill the mites, something we've been calling the Fight the Mite initiative. And so I'm going to take you through both of those segments because I've already started both segments of this initiative. I haven't been able to finish either of them because the pandemic had something to say about that project, but that doesn't mean that there aren't worthwhile things to say about what's occurring here. Now, Varroa destructor is already a very problematic organism to deal with. And this is data from the Ramsey Research Foundation that you're seeing in motion here. And see these mites feeding on the bees, know that even though it may seem like this is a tiny organism here, it can do a lot of damage actually quite rapidly. You can see how its mouth parts right here are piercing through the body of the bees and accessing all of this fat body tissue under it. They're releasing digestive enzymes that are breaking down that fat body into a fluid such that it is no longer a contiguous, cohesive organ, and that causes a weakening of the immune system of the bees, greater susceptibility to pesticides. They're able to transmit viruses. It causes desiccation, reduction in metabolic activity, and usually the early death of the host. So we've learned a lot about Varroa in the amount of time that we've been studying it. But the tropy mites, there's still more to learn, and looking at them inside of these brood cells is going to tell us a lot. We can really get the opportunity to experience how quickly these organisms are able to reproduce, what it takes for them to reproduce, where they feed on the host, how they interact with other organisms, because there are still so many open questions abounding. We don't know, like we know of Varroa, all the different things that the tropy mites do to the different bees. We know that they create developmental abnormalities. We know that they can transmit viruses, but the rest is kind of a blur. And so we are working to better understand all of that as we go. Now, one of the great things about this system is that as the bees are developing into adult bees and we are watching these parasitic mites walk around inside the colony, I'm able to collect all of this data and compile it into a behavioral analysis software called the Observer, which allows me to determine both everything that these parasites are doing inside of the colony, but also compare them in a giant pie chart of this is the amount of time they spend walking inside of the colony, the amount of time that they spend feeding, this is the amount of time they spend mating, laying eggs. All of that data is incredibly useful because it allows us to understand these organisms, and knowing your enemy is the first part of the battle. We can also compare them to Varroa and see the differences between the two parasites, and then we can search for weak links in the life cycle of this organism. If you'll watch the video that you were just seeing a moment ago, you'll notice something really fascinating. That's Varroa destructor at the bottom of the cell. And something that I've already been able to determine through these videos that we haven't been able to determine since then is that Varroa has the segment of its life cycle where it has to crawl under the brood, flip itself over, and lie upside down in the brood food at the bottom of the cell. And this period of time ranges anywhere from 2 to 12 hours of time where it just sits upside down in the brood food. If you disrupt this process from occurring, the parasite does not go into its reproductive processes. It does not lay eggs. It seems to be an essential and very vulnerable element of Varroa's life cycle, and we're not sure what it's doing, but some element of what it's doing is preparing it for the reproductive processes ahead. We were hoping that Tropy had a similarly vulnerable element of its life cycle that we could attempt to exploit, but it doesn't seem to do that. The Tropy mites enter the cell and are able to immediately begin feeding and reproducing on that host. So we're already elucidating differences between these parasites as we go. Now, special equipment is used in this setup. There's high optical clarity glass that is then used to create a window into these cells. So there are, of course, in a hexagon, 6 walls. We replace 2 of these walls with this high optical clarity glass that allows us a perfect window to look into the cell. But we wanted this system to be as similar to the natural system that the parasites were going to be in as is possible. One of the things that we don't need to be concerned with is the light that's shining on these parasitic mites, because they can't see, they don't have eyes. And so they're not going to be disturbed by the light, but the light does need to be fairly dim because the heat of the light can be very problematic. These mites aren't able to thermoregulate. But creating that high optical clarity glass window allows us to see straight through and capture video at very, very, very high resolution. And so as we place these half glass, half wax cells into the colony, the bees can continue feeding them and can actually cap these cells such that we can remove them from the colony, put them under a microscope inside of an incubator at constant humidity and constant temperature, and watch the rest of their life cycle. This system is called the Mite Insight system, as I explained earlier, and this camera rests on top of this microscope, which rests on top of the incubator, which is attached to this relay recorder, which allows us to record continuously for more than 2 weeks if necessary. So this is one of my best friends. The fact that this thing allows me to not have to constantly keep changing out hard drives. This one continues recording when this one is full, and then I can switch that drive out and it'll flip over back and forth between them. It is an amazing system. But as I explained earlier, we've been collecting all this data to determine how long the parasites are feeding, how long that dormant period is that we were discussing before, how long do the parasites spend ovipositing. You can actually see Tropy at the bottom of the cell right now laying a very strangely colored egg that it appears to be pumping fluid into. All of these things that you're seeing here are behaviors that are being compiled for this process, but unfortunately, that section was cut short as well. I'll be heading back to Thailand in October to continue collecting data in this process, and will hopefully be done by early spring of next year, such that I can provide you guys with those wonderful charts and graphs that we were discussing earlier, showing you the exact amount of time that they spend at all of these different behaviors while inside the cell. But oftentimes, the things that people are most interested in, and I'm going to move past that video because I really want to get to this part and allow you some time for question and answer. The part that people really get very interested in is, how do we kill these things? The question that I was detailing to you earlier about what can be used against them. Well, if we're going to fight the mite, we have to remember how this mite works. Now, the period of time where we typically employ chemical means of remediation against Varroa is the period of time where the Varroa mites are on the adult bee population. But with Varroa spending a week to 2 weeks on the adult bees, and Tropy mites only spending a few hours on the adult bees, there's not a very large window for the Tropy mites. And that means that it's not going to be a very efficient period of time for us to attempt to target that at any point. the time that we really need to be targeting is the period of time where the mites are under the cell capping. And what are methods of treating for mites when they're under the cell capping? Well, I'm glad you asked, because I've decided to employ a couple. Now, I had a lot of colonies for this process. I started with 48, moved up to 96. And so in 3 different colonies in northern Thailand and 3 different colonies a little bit south of there, we were able, or I said 3 different colonies, 3 different locations with 16 colonies in each location in northern Thailand and then a little farther south. We also had 3 different locations with 16 colonies. And then I need to do this one more time for that 3rd set of replication to continue this process, and then we'll have the full distribution. But that's 96 colonies altogether. We started with 48 and just kept it moving. The problem there now is that I can't just return to that area and keep that work going, because those colonies have all been cleaned out by giant hornets. So, you know, these are things that happen. But the different locations were all locations where there was a water source and a really good source of forage, such that the bees would be as healthy as possible, and we could attribute the issues that we were seeing to them primarily to the progression of disease and parasites within the colonies. All of these colonies were labeled, and every single frame of every colony, or every single frame of every colony, was also labeled. These unique identifying labels allowed us to distinguish between every frame and every colony, such that we could determine things like queen events, such that we could determine the amount of food in each colony and the impact that any of the treatment measures that we utilized had on the health of the colony itself. So that's me there labeling, and one of the 2 assistants that I worked with, who served as a translator and lab technician. You can see them here. I was trying to figure out, guys, how am I going to move 48 colonies? And they're like, shh, don't worry about it. We got this. And this counterbalance is kind of the coolest thing ever, because I mean, it's literally a stick with some rope attached to it and those clips at the bottom, but they are the best thing ever, and you guys should get you some when you get a chance. Now, Formic Pro is really one of the mechanisms for usage against the mites that I was very interested in, specifically because of its dual action approach. It can impact the population of mites outside of the cells, but it also can impact the population of the mites inside of the cells. You have to use the most concentrated of the labeled dosages there. So if you decide to go with the half dosage, it will not become concentrated enough to penetrate the cell capping, but a full dosage will do so. The full dosage is one that scares people sometimes, because it will cause some level of die-off of some of your open brood, especially under circumstances where it is very hot or very humid. But it can be worthwhile if you really got some parasites in there that you need to take out. So I was very interested in the utilization of this particular option. And you can see that the bees accepted it pretty well, even in the substantial heat of Thailand. And I looked for days where it would not be particularly hot. So I went during the Thailand winter, where it was unlikely to be above 84 degrees most of the time. Now, I want you to compare that to consideration of how some individuals in Southeast Asia have been trying to treat for their mites. Know that there is not a single chemical that is labeled for the treatment of tropy mites anywhere in the world. That's the reason why I've been getting the EPA involved in this process. The formic acid, people have been talking about formic acid usage against Varroa, and somewhere along the way it caught on that maybe they could use some formic against the mites. And so they've been soaking industrial strength formic acid, 85% concentrated formic acid, very corrosive. It will cause severe skin burns if you touch it. And if you are not wearing a respirator, it will do just deeply unpleasant things to your lungs. So this is not the kind of stuff where you can ignore the PPE requirements that you see on the packaging. This will hurt you, and it will hurt you badly. But I was wearing a good respirator and gloves, and I tried the method that I was told that some beekeepers in Thailand have been using. And you soak these overnight in industrial strength formic, and then you push these paint dowels into the colony. And I want you to look here at how the bees responded to this process. So that's me pushing them into the colony, wearing my respirator and my gloves. And just look at the bees just boiling out of the colony. They can't get away from that stuff fast enough. It is caustic, it is corrosive, and they do not like it. But the concern is not the adult bees. The concern is the population of parasitic mites that are in the brood. And so the brood is not capable of leaving the colony, no matter how unpleasant it may find this particular treatment method. And I was using this as a mechanism for comparison with the formic, the regular formic, applied the method in which we use in the United States. Notice, same chemical, substantially lower concentration, the bees are just chilling. Doesn't seem to be bothering them at all. And then heat treatment. I wanted there to be a non-chemical treatment option. We have been on something of a pesticide treadmill for a long time now. And for us to have options that are non-chemical options allow for people to not just rotate between options, but choose something that is not going to cause them to put more chemicals into the environment, because we should be thinking about more responsible usage, or more responsible management of the world around us. And so considering non-chemical options is very important. This one heats the colony to 106 degrees Fahrenheit for 160 minutes and is potentially able to impact the population of mites under the cell capping as well. You can see in these colonies that I have attached these heating pads to. It works best in these smaller colony contexts. When you get to contexts with larger and larger stacked colonies, it gets a lot more difficult for this heating pad to get the entire colony up to that temperature. So I've been testing these on a single box. Randy Oliver has been testing them on larger colonies and been getting substantially less efficacy in his numbers. And you'll see that a lot of the bees are on the outside of the colony. In my time checking just 2 of them, so I've done this a bunch of times, I've only checked twice, but then times where I've checked, the queen has actually been at the center of that cluster, and I anticipate that she is in all of them, out of concern that those really high temperatures could potentially damage the sperm that's currently stored in the spermatotheca. And a few bees do die in the process as they land on that heating pad, and it potentially is too hot for them to get off of it before they die. But it's a pretty small amount of bees by comparison to what's inside the colony, no more than a few dozen. Now, we conduct these frame-by-frame inspections because there isn't a really easy way to determine the health of the colony without looking very consistently at what happens on these frames. And so we expose the colony to the treatment, and then the day before we expose them to the treatment, we inspect every single frame, and we take a picture of each frame front and back, and then log that into this huge spreadsheet that I have. I mean, the amount of data on this spreadsheet is ridiculous at this point, but it's organized well to each of these colonies and allows us to see the progression of that colony across across a substantial amount of time, because you go from that first week where you have taken a picture of that, and then you expose them to treatment, and then the day after you've exposed them to treatment, we do another round of taking pictures of all of the frames. And then at intervals of 1 week, we collect data for an entire month after that to see which of the colonies do better, how soon the mites will invade those colonies, and then we do one more check 3 months later to see how many mites have reinvaded at that point. Those frame-by-frame inspections can tell you a lot about whether the particular method of treatment immediately induces a queen event, whether there's a lot of brood that dies as a result of it, and the brood pattern changes, whether brood is being removed from cells. All of that can be determined with this very, very watchful eye of the camera. And then colony inspection from the top down can also show you how many seams of healthy bees you have when you open the colony. There's also the 100 cell inspection, which is a way of replacing the typical method of evaluating the number of mites within a colony. Normally, you would get half a cup of bees, you would dump powdered sugar on them, or you would just do an alcohol wash and you would count the amount of mites that were on that population of adult bees. You may already be ahead of me at this point in knowing that that is not going to work for the tropy mites. And because we didn't have that easy method in place for the tropy mites, I actually had to do a 100 cell inspection. This was my way of replacing that system by actually going through and opening 100 brood cells at random. So every week, we took a frame out of the colony, and before and after each treatment, the day before and the day after each treatment, then 1 week after each point, we then took a frame out of the colony and opened 100 cells to see how many mites were alive inside of these cells, how well the brood was doing under these capped cells, looking at the age and health of a parent brood, and looking at any of the brood that had been uncapped as well. So these are the remnants of those 100 cells. You can see that all of them lined up. I would also place next to them any of the parasites that had been shown after I'd killed them to make sure they didn't run away. And then we can then see just how many of them were present in this system and how healthy the brood was. And this was one of the methods that I've been using of actually displaying this data to you. If you see a white hexagon, so there are 100 here. If you see a white hexagon for the 100 cell inspection, that is a cell in which there was just a normal, healthy brood present inside. But if you see this silhouette of a tropy mite, there was a tropy mite inside of the cell. If you see the large one next to the smaller one, you know that there was a reproducing mite inside of the cell. And then if you see the silhouette of Varroa next to tropy, both of them were inside of the same cell. So you can see this is data, this is actual data from heat treatment colony 5, and this is frame E. And you can see the number of them that were present in this cell. And then you can see after heat treatment, just how many of them were killed by this process. We actually got to 100% mortality for some of the treatments that we're using in this process. But I cannot, until I have the full complement of data for this system, I'm not going to make any conclusions or any pronouncements that would be just generally irresponsible as scientists. And so I will tell you guys my pronouncements about this sort of stuff after I come back from Thailand this time around. But in general, I can give you some general observations that Formic Pro, Formic utilized the Thai method and heat treatment, achieved high levels of immediate mite reduction and similarly high levels between them. But the greatest amount of die-off from the bees was achieved in the one where I stuffed those formic acid impregnated paint stirrers directly into the colony. That seemed to be very, very, very damaging to the adult bee population, which is not even remotely surprising. The heat treatment colonies were the ones where the mites reinvaded the most quickly, and the Formic Pro colonies were the ones where queens were most consistently impacted by the treatment. Those are just preliminary observations. I will have more information for you later. This next time when I return to Thailand, I'll be conducting my work in Bangkok, and one of the most exciting things here is that they've got these gigantic statues. One of them I just used to drive by all the time and admire this gentleman's beard, until I realized that's no beard. Everyone, those are giant honeybees, and those giant honeybees are actually the original host of the tropy mites. Why is that so important? If you want to know how to impact these populations of organisms, you need to see how the natural host does it. And so thanks to connections with Thai monks and how much they love bees, they're willing to let me do some experimentation on their bee populations. And so I'm going to be looking at some of the giant honeybees, and I'm really excited. Okay, so I want to thank everyone who was involved in this project. And wait, yes, I'd like to thank everyone involved in this process so far for all of their help. This experience has just been very, 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 very it has very much been a team effort and involved a lot of people from Jay Evans, Steve Cook, Max O'Grady, Don Lopez, Zach Lamas, Daniel Sunshine, as well as the Bee Protection Lab in Chiang Mai, Thailand, Sasaprapa Kongdang, Patran Fokasim, Chainarong Wasin, and Nafakon. All of them were really helpful in this project, as well as Mike's Bees and Trees, Manuka Doctor, D&J Apiaries, and you guys, the engaged and informed beekeeper community, because this program sponsored in part
was made possible
by viewers like
like
you.
you. Thank you.
And if you want to continue supporting this process, the big difference now is that I have a nonprofit. And so instead of donating through things like GoFundMe, you can actually get a tax break through donations to the Fight the Mite campaign and to the Ramsey Research Foundation. If you go to www.ramseyresearchfoundation.org and click on any of the many donate links, you can find this process and donate and receive a tax break in the process. So thank you very much for all the support that you've shown thus far and for listening to this presentation. And if there are any questions, I know it's 11:30 or almost 11:30 here, but I would still love to answer any questions you might have.
That was fantastic. Thank you so much. And yes, nightmares will be the next thing that happens.
I'm sorry.
I know that's okay, and you've got to deal with reality. I tell you, I just spaced out. And in your research in Thailand, are you working with the Apis cerana, or are you working with mellifera over there?
So I'm working with Apis mellifera.
Okay.
There are some Apis cerana colonies that I've been observing just to understand better how Apis cerana manage parasites, because Apis cerana, out of all of the bee populations, seem to be the best at parasite management, then Apis dorsata, and then the rest of the bees. And so I've done a little bit of work with them, but not nearly as much work as I've done with Apis mellifera, because those are the bees we have in the US, and the greatest direct translation will come from those bees.
So what does cerana do that is so, I mean, I understand what the dorsata do, they just fly away, but how is cerana managing this mite?
They are so good at what they do that it upsets me sometimes. Apis cerana, they make our bees look like they just don't know anything. So Apis mellifera bees have some pretty fancy dances, right? You got your waggle dance, your round dance, then that's pretty much it. Well, Apis cerana have another set of dances. They have grooming dances where they do this very frenetic, crazy looking dance because they know that they're not capable of removing a parasite that's between their thorax and their abdomen. It's analogous to the region of your body that's the small of your back that you can't really reach and you have to get another person to scratch it. Well, the bees are able to elicit the other bees in the colony to groom their bodies and remove those parasites. It's very effective against the tropy mites during the very brief period of time where they're on adult bees, for the Apis cerana workers to immediately go into this weird dance that they do, such that all the bees that they touch while dancing jump onto them and just start combing their body until they pull off whatever foreign object is there. So that's one method. The other method is that there is this weird system where the brood seems to go through something analogous to apoptosis, where it will kind of die if it interacts with the proteins from the saliva of these parasitic mites, from Varroa and potentially also from Tropicolaps, it seems to be the case. The brood will just die. And as a result of that, because the cell is sealed already, the parasite can't get out of the cell by itself. And by going inside, it has sealed its own fate. Our bees just don't behave the same way.
That's amazing.
Isn't it though?
Yes. Okay, so Susie asks, so Susie says, yes, absolutely fantastic presentation. Yes, we know Dr. Sammy's a rock star, so we feel really privileged and special. Does anybody else have any questions? And if you want to, you can just press your space bar and ask, or you can type them in.
Sammy, this is Dewey.
Hey, Dewey.
Fascinating with that star that we're hearing from Pakistan. Is there some threat also to Apis mellifera in Thailand as from what you've heard and what you've seen?
The beekeepers in Thailand have been dealing with trophy mites in Apis mellifera colonies for far longer than the beekeepers in Pakistan. Because the beekeepers in Pakistan had no idea what to do about something like this, their colonies were just sitting ducks and died very rapidly. Thailand is the place where I learned that there were actually beekeepers pushing these sticks of industrial strength formic into their colonies. And while it is not the best thing in the world, it does work. It will definitely get rid of the population of trophy mites in your colony. It'll get rid of a lot of bees in the process too. But what they do, so that'll be a treatment they may do a couple of times a year. But the primary means of keeping these mite populations under control is getting rid of brood. And so the honey production for the entire country of Thailand took a dramatic tumble when trophy mites came into the works, because in order to stop their populations from growing and reproducing, you have to really be looking at the brood area in your colony. When the brood area gets too large, you just take all of that brood out, you get rid of it, and you let the bees expand out again. And so that's not a great system, but it works, and it works really well. It doesn't work if you want to be a beekeeper with a very productive colony. It doesn't work if you want a contract strength colony to take to the almonds. It doesn't work if you want to produce honey, but it does work if you want to keep those colonies alive.
Okay, interesting.
Well, I guess if we're doing inspections, it seems like, I mean, we're just having a hard time now. Even, you see what you want to see, you see what you expect to see. I can't even imagine pulling a frame up and it having even crossed my consciousness, except maybe now it will, to look for something so small that moves so fast.
Yeah.
So what type of surveillance are we doing now in the United States? Any surveillance at all?
Well, I can tell you we're not doing enough, but we are doing more now. So I've been making a lot of noise and shaking a lot of trees and annoying a lot of people, both within and without the US government. But I just don't want us to get caught off guard by this the way that we were with Varroa. When Varroa arrived, we kind of had a wait and see attitude. We waited until it got into the country, and then we started making noise about it and getting nervous about it. And I want us to be aware of this creature before it arrives, and to have an emergency response system in place. The worst time to be trying to develop an emergency response system to, I don't know, figure out what to do in an emergency in your own house is when someone is yelling in your face, fire! Like, that's not when you want to do it. So I'm working on developing an emergency response system with the Animal Plant Health Inspection Service right now, and you guys should be seeing something from that within the next several months. But that also includes with it a system of consistent analysis where people at all of the ports of entry are consistently looking for this organism such that we have an immediate early response. My other method for this is to just tell as many beekeepers as possible, as many state inspectors as possible, give as many presentations as possible, where a lot of people will then know what this organism looks like, what to associate with this presence, how quickly it moves and all of that. And it gets people on alert.
And if we did, for any odd reason, think that we had an odd looking mite, would we just send it to our local ag extension agent?
Yes,
Okay.
absolutely. And if your ag extension agent thinks that it is a trophy mite or isn't sure, they will forward it to APHIS, and we will let you know for absolute sure. Those come to me. I've already seen a few. Most of what I've seen so far have been Phytocoelus mites. They look a lot like trophy mites, but if you get them under a microscope, you can tell the difference pretty well.
Great.
Cheryl and Sammy, as a little follow-up, the apiary there at Pub has been included this year and last year as well in the sampling that we are doing in Oregon, which is part of APHIS. It's not an Oregon program. It's across all of the states, 30-some states participating. And that does include a sample of brood that is an effort to look for the trophy mite. So
Sweet.
that apiary was sampled this past year.
Great.
Awesome. I'm so glad to hear that.
Okay, well, I don't see any other questions in the chat box, and nobody else is piped up, so I guess we'll let you go to bed. Um, if you're that kind of person who doesn't stay up till 2. But thank you so much. It was wonderful, and we will hopefully have you back after your trip to Thailand.
Looking
Enjoy
forward
the
to it.
yes, enjoy your time over there. It's a lovely country, and
Yes, it is.
thank you so much.
Thank you. And you guys have a great evening. And yeah, thanks again for listening.
Well, thank you. Good night,
Thank you,
Sammy.
Sammy. Good evening. Take care.
Good night, all.